Welcome to Statistics Made Simple, and I am Savita Walsang. In this video, I will find solutions to the 10-mark questions in the new pattern question paper. Section D, 7th main, answer any two of the following questions. So there will be 4 questions and each question will carry 10 marks and you have to answer any two of them. So 10 into 2 is equal to 20. So please practice this question, that is standardized death rates. It's an important one and it is a sure question. 37th one. For the following two towns, compute standardized death rates and comment. So in the first column, we have age in years 0 to 20, 20 to 40, 40 to 60, greater than or equal to 60. The standard population values are 6,000, 12,000, 8,000, 4,000. Town A is divided into population and deaths. Population values are 4,000, 9,000, 7,000, 3,000 and the deaths are 72, 54, 98, 129. For Town B, population values are 8,000, 13,000, 10,000, 4,000 and the deaths are 128, 65, 140, 160. So let us start with the solution. So first we will write STDR formula. So STDR of A is equal to summation PA divided by summation P. Similarly, STDR of B is summation PB by summation P. Next, it is very important to write ASDR formula, that is age specific death rate, that is number of deaths occurring in a specific age group in a year divided by average population in a specific age group in a year into 1000. So now let me mark the standard population column as capital P. This is important. I will mark standard population as capital P as I had done earlier. Next, add up the values in this column to calculate summation P, which will be equal to 30,000. So now what we have to do is we have to form a table where we calculate ASDR for town A and for town B, and then we have another two columns, that is PA and PB. Okay, so how do we find out ASDR? It is the deaths divided by the population in a specific age group into 1000. As an example, like if I want to calculate ASDR for town A. Okay, so I'm calculating ASDR for town A for the age group, that is 0 to 20. The formula will be 72 divided by 4000 into 1000. Okay, so if I simplify, I will get the answer as 18. Similarly, if every death will be divided by the population into 1000 for a particular town, we will get the ASDR values. The next one here is 6, then we have 14, and then we have 43. Similarly, for town B, 128 divided by 8000 into 1000 will give the ASDR for the age group 0 to 20, which is 16. Similarly, the next one will be 5. Then we have 14 and then 40. The next step is to find out PA. That means the first standard population value for the age group 0 to 20 will be multiplied with the ASDR, that is 18. So 6000 into 18 will give 1,08,000. Similarly, the next one is 72,000. Next, we have 1,12,000. Then we have 1,72,000. Then add up these values to obtain summation PA, which is 4,64,000. Similarly, find out PB, that is 6,000 into 16 will give 96,000. The next one is 60,000. Then 12,000, and then we have 1,60,000. Add up the values in this column to obtain summation PB, which is 4,28,000. Now let us substitute in the formula for STDR of A and STDR of B and get the values. So I will consider STDR of A. What was STDR of A formula? It was summation PA divided by summation P, so which is equal to 4,64,000 divided by 30,000. So if I simplify, I will get 15.47. You can just take two places after the decimal after rounding off, and similarly you find out STDR of B. So STDR of B will be summation PB divided by summation P, which is equal to 4,28,000 divided by 30,000. On simplification, we will get 14.27. Next, we have to comment. So for the comment, we should find out which of the STDRs are lesser. So now let us write the last part, which is the conclusion. So start with the lesser STDR value. Since STDR of B is equal to 14.27 is less than STDR of A, which is equal to 15.47. So you'll conclude that town B is healthier. So always remember, for whichever town, locality or population the STDR value is lesser, that town, population or city would be healthier. So do practice this question. It is an important one. 38th question is another important one. Do practice these kind of problems. For the following data show that Fisher's index number satisfies both time reversal test and factor reversal test. And even if they ask us to verify whether Fisher's index number is an ideal index number, even in that case, we have to show that it satisfies TRT and FRT. So the items given are A, B, C, D. The base year prices are 60, 50, 80, 120. The quantities in the base year are 15, 10, 12, 20. The current year prices are 80, 70, 120, 150. And the current year quantities are 20, 18, 15 and 24. Now the first step is to read the headings of each of the columns and then mark the columns correctly. So first, now let me mark the price in the base year. So remember that the base year is denoted by 0 and the current year is denoted by 1. So price in the base year means it is P0. Use small p. Similarly, quantity in the base year is Q0. The price in the current year is P1. And the quantity in the current year is denoted by Q1. Now it is important to form next these four columns. These four column totals will carry 4 marks. Okay, so do the calculations carefully. So let us now find out P0 into Q0, then P1 Q1, P1 Q0 and P0 Q1. The order of the columns is not important, but do the calculations carefully. So it is 60 into 15 will give us 900. Similarly, the next value is 500. Then I have 960 and then 2400. So summation P0 Q0. Like I said, it's important to get the totals right because each of the totals will carry 1 mark. So we get 4760. Similarly, now find out P1 Q1. So 80 into 20. So you will get 1600. Similarly, 1260 then 1800, 3600. Similarly, find out this total, that is summation P1Q1, which is 8260. The next column is P1Q0, that is 80 into 15 is 1200. Similarly, calculate the next one, you will get 700. Then it is 1440 and the next is 3000. So summation P1Q0 is equal to 6340. The last column is P0Q1. So it is 60 into 20 is 1200. Then we have 900, 1200, 2880. So I get summation P0Q1 is equal to 6180. So first let us start with the time reversal test. To keep it short, I'll write for the time reversal test. The condition is P01 of f into P10 of f is equal to 1. So this is very important. It will carry 1 mark. Now let us write the formula for P01 of f. So remember that P01 of f, or Fisher's price index number, is the geometric mean of last pairs and Paget's price index numbers. So consider P01 of f, which is equal to root of. So how to remember the formula is first write summation P1 divided by summation P0. Then multiply the numerator and denominator by Q0. So this is last pairs without the 100. Next, into summation P1 divided by summation P0. Then multiply the numerator and denominator by Q1, which is Paget's without the 100. Now, because we are doing the time reversal test, you have to ignore 100. Don't write 100 when you're writing the formula. So this is very important for the time reversal test and factor reversal test. Write the formula without the 100. Now same way you have to write the formula for P01 of f. So if you have written P01 of f formula correctly, all you have to do is replace 1 by 0 and 0 by 1, but P and Q will remain the same. So I will get now summation P0 Q1 divided by summation P1 Q1. This is multiplied by summation P0 Q0 divided by summation P1 Q0. Now again you should not write 100. Now we have to multiply both these index numbers. Okay, that's what it is indicated in the left hand side of time reversal test. So now I will write consider P01 of f into P10 of f, which is equal to, you draw a long square root and write the totals for all these 8 calculations. Okay, so first I will write for summation P1 Q0. So summation P1 Q0 was 6340. Summation P0 Q0 was 4760. This you have to multiply by summation P1 Q1, that is 8260, divided by summation P0 Q1 is 6180 into summation P0 Q1 is 6180 divided by summation P1 Q1 is 8260 into summation P0 Q0 is 4760 divided by summation P1 Q0 is 6340. So now you will see that all the values in the numerator and in the denominator will get cancelled. That is, the corresponding totals will get cancelled and you will get root 1 which is equal to 1. So therefore P01 of f into P10 of f is equal to 1. So you can write therefore Fisher's index number satisfies TRT. So like I mentioned, the 4 totals will carry 1 mark. This TRT condition will carry 1 mark and this calculation will carry 2 marks. So till here it will be 7 marks. Now second subdivision, let us do the factor reversal test. So for the factor reversal test, that is FRT, we have to prove that P01 of f, that is Fisher's price index number, into the Fisher's quantity index number, that is Q01 of f, is equal to summation P1 Q1 divided by summation P0 Q0. Now even this is important and it will carry 1 mark. So now let us write the formula for P01 of f like we had already written previously. So consider P01 of f. I will write it quickly now because I have already explained how to write the formula. It is summation P1 Q0 divided by summation P0 Q0 into summation P1 Q1 divided by summation P0 Q1. Now important is you have to ignore 100 when you are doing the TRT and FRT. Now let us write the formula for Q01 of f. So how do you write the formula for Q01 of f? In this Fisher's price index formula, where you have P, you have to put Q and Q will get replaced by P, but 1 and 0 will remain the same. So it is summation Q1 P0 divided by summation Q0 P0 into summation Q1 P1 divided by summation Q0 P1. Now you have to multiply P01 of f and Q01 of f. So therefore P01 of f into Q01 of f is equal to, draw again a long square root and then you have to replace all these 8 totals from the values in the table. So summation P1 Q0 is 6340. Summation P0 Q0 is 4760. Summation P1 Q1 is 8260 and summation P0 Q1 is 6180. So into next summation Q1 P0. So summation Q1 P0, please see carefully from the table, is 6180 and summation Q0 P0 is 4760. Summation Q1 P1 is 8260 and summation Q0 P1 is 6340. Now note that summation P1 Q1 will be the same as summation Q1 P1. So check the values carefully from the table. Now only 4 values will get cancelled. So 6340 and 6340 get cancelled and then 6180 and 6180 gets cancelled. So what remains now is 8260 into 8260 in the numerator divided by 4760 into 4760 in the denominator. So this can be written as 8260 divided by 4760 the whole square. Okay, next the square and the root will get cancelled and you will be left with 8260 divided by 4760. Now don't simplify. All you have to do is check what is 8260 in the table. So if you check, 8260 is nothing but summation P1 Q1, and 4760 will be summation P0 Q0. Okay, so you have shown that P01 of F into Q01 of F is equal to summation P1 Q1 by summation P0 Q0. That is what we had to prove for FRT. So your conclusion will be, therefore, Fisher's index number satisfies FRT. So these calculations will carry 2 marks. So the 4 totals will carry 1 mark each. Then TRT will carry 1 mark. The calculations will carry 2 marks. Similarly, FRT condition will carry 1 mark and the calculations will carry 2 marks. 39 question. Fit a straight line trend for the following time series. Obtain the trend values and estimate the value for the year 2011. The years are from 2005 till 2010 and the corresponding values are 25, 15, 20, 18, 13 and 14. Now let us first start with the solution. So under solution, I will write given the number of years, that is n. So totally the number of years are 6 and 6 is an even number. Now let us first write, let y equal to a plus bx be the straight line equation. Now the straight line equation is also called as the linear equation, or it is also called as the first degree equation. Now our aim is to find out the two constants a and b. So for that we have to use two normal equations. So in the next line I'll write the two normal equations are, first one, NA plus B summation X is equal to summation Y, and second, A summation X plus B summation X square is equal to summation XY. Now these are important and they'll help us to get the two values A and B. Now in the table, we can mark year as X and value as Y. Now if you observe, the X values are 4-digit numbers because they are the years, and if we calculate X square, then it will become huge. So to avoid difficulties in calculations, we will use a different formula for X so that the value will become smaller. Now whenever n is equal to an even number, we won't get the middlemost year, but we will get two middle years. So now if you observe, the two middle years in this particular problem are 2007 and 2008. Okay, so now I will show you how to calculate the new X values. So whenever n is even, the formula we use for X is deviation from the arithmetic mean of the two middle years divided by h by 2. So where h is nothing but the difference between the years. And when n is odd, x will be deviation from the middlemost value divided by h. So if you refer to my videos on fitting of a straight line trend, you can understand this concept better. So for this particular problem, it will be deviation from, it is 2007 plus 2008 divided by 2 whole divided by h is a difference between the values, which is 1, divided by 2. So finally you get x is equal to deviation from 2007.5 divided by half is 0.5. So I'll show you how to obtain x in my next slide. I have marked years as x and value as y. So let us first find out summation y. So when we add up the y values, we get summation y as 105. Now let us find out x. So if you remember in the previous slide, x was deviation from 2007.5 divided by 0.5. So as an example, take the year 2005, subtract 2007.5 whole divided by 0.5. So this is equal to minus 2.5 divided by 0.5, which is equal to minus 5. So let us write minus 5 here. Similarly, 2006 minus 2007.5 divided by 0.5 will give us minus 3. Next will be minus 1. Then we will have 1, 3 and 5. Our aim is always to make summation x equal to 0. Next, find out x square. So whenever you square a negative value, it becomes positive. So minus 5 square, 25. Then you get 9, 1, 1, 9 and 25. So add up this particular column and you'll get summation x square is equal to 70. Next is xy. So it is 25 into minus 5 minus 125. Then you have minus 45 minus 20. Then you have 18, 39 and 70. So summation xy is equal to minus 63. Now let us substitute these totals in the two normal equations. So let me consider the first normal equation. So it was NA. So 6A plus B summation x. So plus B into 0 is equal to summation y. So summation y is 105. So which implies 6A is equal to 105, which implies A is equal to 105 divided by 6, which is equal to 17.5. So we get A is equal to 17.5. Now similarly, take the second normal equation. It was A summation x. So A into 0 plus B summation x square. So B into 70 is equal to summation xy, which is minus 63. So which implies 70B is equal to minus 63, or which implies B is equal to minus 63 divided by 70, which is equal to minus 0.9. So therefore, B is equal to minus 0.9. So now that we have obtained the values of A and B, we substitute them back in the given straight line equation to obtain what is called as a fitted straight line trend equation. So now we'll write, therefore, the fitted straight line trend equation is y subscript c is equal to, substitute the value of A, that is 17.5 minus 0.9x, because the equation is y equal to A plus bx. So in place of A, substitute 17.5 and for B minus 0.9x. Next, they have told us to obtain the trend values. So side heading, I will write trend values. So for different values of x, we have to substitute in the fitted straight line trend equation and get the corresponding y values. So when x is equal to minus 5, the value of y, that is for the year 2005, will be equal to 17.5 minus 0.9 into minus 5, which is 17.5 minus into minus becomes plus 4.5, which is equal to 22. Similarly, when x is equal to minus 3, that is y 2006 will be equal to 17.5 minus 0.9 into minus 3, which is equal to 17.5 plus 2.7, which is equal to 20.2. Similarly, when x is equal to minus 1, y 2007 is equal to 17.5 minus 0.9 into minus 1, which is 17.5 plus 0.9, which is equal to 18.4. Then when x is equal to 1, y 2008 is equal to 17.5 minus 0.9 into 1, which is equal to 17.5 minus 0.9, which is 16.6. Then when x is equal to 3, y 2009 is equal to 17.5 minus 0.9 into 3, which is equal to 17.5 minus 2.7, that is 14.8. Then when x is equal to 5, y 2010 is equal to 17.5 minus 0.9 into 5, which is 17.5 minus 4.5, which is equal to 13. So after obtaining the trend values, they have also said that we have to estimate the value for the year 2011. So I'll write the side heading as estimate for the year 2011. This is quite simple. So we know that when the year was 2009, the x value was 3. For 2010, the x value is 5. So observe that the difference is 2. So it means that for the year 2011, the value of x will be 7. So when x is equal to 7, y 2011 is equal to 17.5 minus 0.9 into 7, which is 17.5 minus 6.3. So the estimate is 11.2. 40th question. Fit a Poisson distribution for the following data and test the goodness of fit at alpha equal to 5% level of significance. The x values are 0, 1, 2, 3, 4, 5 greater than or equal to 6. So please be careful here. And the corresponding frequencies are 18, 43, 45, 28, 12, 4 and 0. I have rewritten the given table again in a column format. Now let us start with the solution. So under solution, first I will write given. Now I will add the frequency. So when I add the frequencies, I will get capital N. So here I will write capital N is equal to 150. Next, so under this given, I'll write capital N is equal to 150 and alpha is equal to 5%. This we will use later when we do the testing of hypothesis, that is goodness of fit. Now, because they have asked us to fit a Poisson distribution, they haven't given us the parameter value with lambda which is required. So whenever lambda is unknown to us, we have to find out the mean of the given problem. Okay, so in the next line, I'll write here, we know that x bar is equal to summation fx divided by capital N. So because the given data is discrete, we use a formula for the arithmetic mean as summation fx by capital N. So now let us find out the fx values in the table. So first I will get 0 into 18 is 0. Please be careful. Next is 43. The next value is 90, 84, 48, 20 and 0. Next, calculate summation fx, which is equal to 285. It is very important that we calculate the mean correctly, otherwise the entire problem will go wrong. So this is equal to 285 divided by 150, which is equal to 1.9. Now what we have to do is we have to equate the mean of the given distribution, that is the Poisson distribution, with the mean of the given problem. So next I will write consider lambda is equal to x bar. So here lambda is the mean of the Poisson distribution. This is only for your understanding. Again, I have explained in my previous videos about this. So lambda is the mean of the Poisson distribution and x bar is the mean of the given problem. So mean of the problem. So when we equate both, we get therefore lambda is equal to 1.9. So now that we have got the value of lambda, we can write down the PMF or the Poisson distribution and then find out the expected frequency. So whenever they ask us to fit a Poisson distribution, we need to find out the expected frequencies first. Now I will write the PMF or the Poisson distribution, and we have got the parameter value lambda as 1.9. So PMF is P of x equal to, it is e to the power minus lambda. So e to the power minus 1.9 lambda to the power x. So 1.9 to the power x divided by x factorial, and x takes the value 0, 1, 2, 3 so on. It is infinite, and then you can write 0 otherwise. So first I will put x equal to 0. So when x is equal to 0, P of 0 is equal to e to the power minus 1.9. 1.9 to the power 0 divided by 0 factorial. So find out e to the power minus 1.9. It is 0.1496. 1.9 to the power 0 will be 1 and 0 factorial is 1. So P of 0 is 0.1496. This calculation should be correct. Now we know that the expected frequencies or the theoretical frequencies are given by Tx equal to capital N into P of x. Now put x equal to 0. So you'll get T0 is equal to capital N. We have already calculated, it is 150 into P of 0, which is equal to 150 into 0.1496, which is equal to 22.44. Now because Tx stands for the expected frequencies or the theoretical frequencies, you have to approximate it to a whole number. So T0 is equal to 22. Similarly, to find out the remaining theoretical frequencies, we'll make use of the recurrence relation between successive frequencies of the Poisson distribution. So I will write the formula. Consider the recurrence relation between successive frequencies. So if you find this difficult, what you can do is, in the PMF itself, you can substitute different values for x, and then after that each of the probabilities can be multiplied with capital N. So now I am considering the recurrence relation between successive frequencies, and that formula is given by Tx is equal to lambda by x t x minus 1. So this formula is important. Now put x equal to 1. So t1 is equal to 1.9 divided by 1, t1 minus 1, which is equal to 1.9 into 22, which is equal to 41.8, which I'll approximate it to 42. Similarly, when x is equal to 2, you will get t2 is equal to 1.9 divided by 2, t2 minus 1, which is equal to 1.9 divided by 2, t1, which is 1.9 by 2 into 42, which simplifies to 40. So now when x is 3, I'll find out what is the theoretical frequency. So when x is equal to 3, t3 is equal to 1.9 divided by 3, t3 minus 1, which is equal to 1.9 divided by 3, t2, which is 1.9 by 3. t2 we had got the value as 40. So this simplifies to 25.3 and you approximate to a whole number, that is 25. Similarly, when x is equal to 4, t4 is equal to 1.9 divided by 4, t4 minus 1, which is 1.9 divided by 4, t3, that is 1.9 by 4, t3 value is 25. So we get t4 as 11.875. So you can approximate it to 12. Similarly, when x is equal to 5, t5 is equal to 1.9 divided by 5, t5 minus 1, which is 1.9 divided by 5, t4, that is 1.9 by 5 into 12, which is 4.56, and on approximation it will become 5. Now we also need to find out t greater than or equal to 6. So when x is greater than or equal to 6. Now learn how to do this calculation. So I have to find out the theoretical frequency when x is greater than or equal to 6. So I'll just write it as t here, greater than or equal to 6. So this is nothing but it is capital N minus, open the bracket, it is the sum of all the theoretical frequencies which we found out, that is T0 plus T1 plus T2 plus T3 plus T4 plus T5. So from the total frequency, if we subtract the sum of the theoretical frequencies which we found out, then we'll get the theoretical frequency when x is greater than or equal to 6. So this is equal to capital N is 150 minus, within brackets we will have first T0 was 22, then T1 is 42, T2 is 40, T3 is 25, T4 is 12 and T5 is 5. So this is equal to, now it will be 150 minus, when we add up the values within the bracket we will get 146. So this is equal to 4. So now we have completed the first part, that is we had to fit a Poisson distribution. So fitting a Poisson distribution means we should find out the theoretical frequencies or the expected frequencies which we have found out. So till here, if you solve the problem correctly, it will carry 5 marks. Now let us check for goodness of fit. So I will write H0. The Poisson distribution is a good fit to the given data. versus H1, Poisson distribution is not a good fit to the given data. Next is we'll write down the test statistic. So under H0, the test statistic is chi-square equal to summation. It will cover both the numerator and denominator. O minus E whole square divided by E, which will follow chi-square with n minus 1 degrees of freedom. So this is the test statistic. Now an important note here is this goodness of fit test is a right-tailed test. So please remember that it is important to make the conclusion. So the goodness of fit test is a right-tailed test. So please note that the frequencies which are given to us in the problem. Okay, so the frequencies given to us in the problem, that is F, are nothing but the observed frequencies. And now for testing of hypothesis, they will be denoted by O. And the expected frequencies or the theoretical frequencies which we just now found out, that is Tx, will be denoted by E. So now let us form a new table with the O values. So O values are the frequencies given to us in the problem, which are 18, 43, 45, 28, 12, 4 and 0. And the Tx values, that is the theoretical frequencies, are nothing but the expected frequencies, which I'll now write it as E. And the values which we got are 22, 42, 40, 25, 12, 5 and 4. Now there is a very important point to keep in mind. All the expected frequencies, okay, so the expected frequencies which are now denoted by E, they should always be greater than or equal to 5. This is very important. Now, if any one of the expected frequencies are less than 5, we have to make use of the method of pooling. Okay, so what we observe here is the expected frequency 4 is less than 5. So we make use of the method of pooling. So I'll just write it here in the box, another note, that is the last expected frequency is less than 5. We use the method of pooling. Please keep this in mind. Okay, even if the observed frequencies are less than 5, it doesn't matter, but all the expected frequencies should be greater than or equal to 5. But now we observe that the last expected frequency is 4. It is less than 5. So we have to make use of what is called as the method of pooling. So now what do we do in this method of pooling is, because there is no value which is there after 4, this 4, which is the last expected frequency, it is added to the preceding value 5. So when I add 4 and 5, I get the value as 9, and 9 is a value which is greater than 5. Now, because we have pooled two values in the expected frequency column, the corresponding observed frequencies also should be added. Otherwise, the number of observations in both the columns will be different. So when I add 0 and 4, I will get 4. Okay, so now you observe that all the expected frequencies are greater than or equal to 5. Okay, so we will rewrite the table again. So now the new observed frequencies are 18, 43, 45, 28, 12, and then write this 4 here. And the expected frequencies are 22, 42, 40, 25, 12. And now the last expected frequency will be 9. Now next let us find out O minus E the whole square. Okay, now how do you find out O minus E the whole square? It is 18 minus 22. Okay, so when I do 18 minus 22, how much will I get? Minus 4. And minus 4, when you square it, it will become 16. Similarly, 43 minus 42 is 1. 1 square is 1. Similarly, do the calculations for the other values. So I'll get 25, then I'll get 9, then 0, and then you will get 25. Now the last column which we have to find out is O minus E whole square by E. Okay, so how do we find out O minus E whole square by E? It will be 16 divided by 22. Now take 4 places after the decimal after rounding off. So you'll get 0.7273. Similarly, when you do 1 divided by 42, you will get 0.0238. The next value is 0.625, then 0.36, then you have 0, and then 2.7778. Now let us find out this total which will be required for the chi-square test statistic. So summation O minus E whole square divided by E is nothing but 4.5139. So now I will rewrite the value which we had got in the previous table. So according to the calculations, now the value of the test statistic is chi-square equal to, it is 4.5139. This is the final answer of the test statistic, which is chi-square. Now to make a conclusion, the most important step next is to find out the degrees of freedom. So the actual degrees of freedom is n minus 1, but because we were not given the value of lambda and we estimated lambda as x bar, we have to subtract 1 degree of freedom. So this is for we estimated lambda. Then we have pooled once. Okay, so we have to subtract 1. And so this one is because we did pooling once. So the degrees of freedom is actually n minus 1. And because the parameter of the Poisson distribution lambda was estimated, we subtract 1. And because we did pooling once, again we have to subtract 1. Now remember, this n stands for the number of independent variates. Okay, so if you see the first column, that is the x values, you will see that the total number of values given are 7. Okay, so it is 7 minus 3, which is equal to 4. Then I told you that this particular test is a right-tailed test. So now let me write at this side what is the condition which has to be used to make a conclusion for a right-tailed test for goodness of fit. So you have to check whether chi-square is greater than or equal to K2, okay, at alpha level of significance for, now in this case it is like n minus 1 degrees of freedom. So if this condition is satisfied, then you reject H0, otherwise you accept H0. So this is an important condition which you have to remember. So now we have got the degrees of freedom as 4. So from the tables, at 5% level of significance, for 4 degrees of freedom, you should find out the value of K2. So K2 value is 9.49 from the statistical table. So now the last part of the problem is to write the conclusion. Now compare the value of chi-square with K2 and then write the conclusion. So conclusion, since chi-square is equal to 4.5139 and you know that K2 is equal to 9.49, check whether chi-square is greater than K2. So you see that it is not greater than K2 at 5% level of significance for 4 degrees of freedom. If it was greater, we would have rejected. Because it is not greater, we accept H0. So when you accept H0, you should write what you have written under H0. So conclude that the Poisson distribution is a good fit to the given data. So fitting of the Poisson distribution will carry 5 marks and testing for its goodness of fit will carry the remaining 5 marks. Do practice the problems, especially from the vital statistics chapter, that is STDR, that is a standardized death rate, and also practice problems on the time reversal test and factor reversal test, along with problems based on Laspeyres, Pachet's, Marshall-Edgeworth, Dobish-Bowley, Fisher's price index numbers and quantity index numbers, which may be asked as 10-mark questions. Thank you all for watching and look out for my next video where I will solve problems on section E from the new pattern question paper.